Good morning, boys and girls. Welcome back to the southern wing of the Stink Bug Works. When I work on a project, I don't clean up my workspace until the project's done. Oh, I may put away tools that I'm not going to use right away, but for the most part, everything stays here at arm's reach. When the project's done, I'll clear everything off and have room for a new project. New projects. See, I always get these interruption projects. This is Saturday. On Monday, Tuesday, Wednesday, Thursday of next week, I have perk tests I need to do down in San Diego somewhere, and God, I think out in Lakeside or La Mesa or someplace. Anyway, I got perk tests all over the county, and I need to go through and what's the word? Not remanufacture, but just make sure my all my equipment's in a trailer that I drag around. I need to bring the trailer over here, make sure everything's handy dandy and up to speed and so forth. I worked on my generator the other day. I put, in fact, yesterday. Changed the oil, put in new spark plugs, changed the air filters, changed the carburetor. You saw me with the carburetor the other day. And so I've got to bring that trailer over here this afternoon and work on it. And so I cleaned out all the eastern part of the stink bug work so I'd have room to move equipment in and out. Haven't done a whole lot on this since the last time. I have worked up the drive line and where it's going to be, and it looks like, I'll show it in a minute. It looks like this is working out pretty well. I got the 5mm shaft. I got the these nice ceramic ball bearings, and I have a choice of a stainless steel sleeve to hold these bearings or this carbon fiber one. And to tell you the truth, I think the carbon fiber one's a little tighter clearance on the inside. I know this bearing is in here real snug. Eventually I'm going to green sauce the bearings into place. That way I can remove them with a little bit of heat and everything will be fine. This carbon fiber sleeve here will eventually get epoxied to this motor mount. And here's the deal. This thing, watch this. Now, I was having a problem with the shaft wobbling before, and so check this out. Now, this sleeve is just sitting here. In fact, let's just take it off. And you can see this is pretty accurate right now. That's pretty darn precise. So, the plan will be, with the motor mounted in place, I will then epoxy and carbon fiber this sleeve into place, and this sleeve will then be exactly where it needs to be. And so I'll feed epoxy and shredded up carbon fiber into here. This hole is about, what do you think? 10 to 15 thousandths larger than the sleeve here, because remember I was originally going to put a grommet in there and use an 1/8 inch shaft out here, and I threw that idea away. This is far more precise. So there we go. Now, let's talk about couplers. For initial testing, I'm thinking of using a rocket motor. A rocket motor has a 4mm shaft. Now I have a number of 4 to 5mm couplers I can throw in there. I can always, I think that's 5. I can always ream that out to 4mm and be pretty darn close. We'll talk about that. But for the initial testing motor, when I put a rocket in here, I could also do one of these 5mm to 4mm shaft adapters, and I think that's what I may do just to keep this Fairlock coupler. Now, this Fairlock coupler, the only drawback with it is it's not light. It's stainless steel. But as you could see, it was precise. So I may, use it to establish the location of these bearings and then come back and use a lighter coupler in here. Now this thing, you're looking at me and going, Doctor, yeah, that sucker is huge. Well, yeah, it's 5mm, and these can be had in all sorts of sizes. But I'm thinking of taking this shaft out and putting the shaft in there, and that shaft's about, yay long. And then running screws. I have some really short M4 stainless steel set screws that I can run down on that clamp, and then I'll chuck this up in the lathe and turn down the outside diameter until the tool almost but not quite touches the top of the fully seated set screws. So I could probably take 3mm off the radius or 6mm off the diameter of this thing just that easily. So there you go, boys and girls. Some of the latest from the jet. Oh, here we go. Got to check this out. One of the reasons I wanted to know where centerline was to see how things line up. And with this motor tucked in, I'm not far off. Well, there we go. Although I got it. I'm not far off of this center line. So if I have to take the flex shaft and lean it a little bit like that, that won't be a problem. So all in all, this is going to work, other than adding a good chunk of weight. But at least that weight's forward of the CG. I may just try to run 2S batteries in the beginning instead of 4S. Not 2S, but 2P instead of 4P. And let the CG drift aft and see what happens. I could always compensate for that with more lift on the prop. So we'll see. So this thing's turning out badass. It's pretty freaking precise, huh? What do you guys think? Other than the weight. The weight. Okay, boys and girls, until next time, jet out. Welcome back, boys and girls, to a special bonus feature from the Stink Bug Works. After I left you, I got to thinking, and I broke out my little scale here and started weighing things. These batteries weigh 65 grams, or that would be 130 grams per side, 260 grams total. Well, I did a little fooling around, and with this little short motor, I managed to shove it as far forward as I possibly could in there and still have room to fit a speed control on top of there and a couple of batteries up here, just one on each side. And guess what? It balanced right about where it needed to balance. Part of that was because I managed to get the motor, the heavy part, much further up. You know, most of this is planning at this stage, and I'm going where no one has gone before. Nobody's ever built one like this. So I'm trying to figure this out. And it dawned on me, if I can save this much weight, use this motor, and actually a 2P should work, because let's look at this. This is 60 amps, and this is 25 to 50 C. Well, what is 25 times 1.2? That's 30 amps. So this battery will give out 30 amps without working hard. Two of them will give out 60 amps without working hard. I can get away with two of these batteries in here and run 60 amps. This motor shouldn't draw more than 60 amps. I may go back to plan A with this motor and put it so far up in there that it'll be hard to access this mounting screw right here. So what do you think, boys and girls? Back to plan A? Run it on a 1005? 1005. See, there I go again. Run it on an 1105? I can get the motor much further up there. Of course, I could get a bigger motor almost up there and get the same weight result. Here's another thought that came to mind. You know, part of the balance thing is at speed, you don't want them blowing off. And so you've got to have them balanced to where when they're flying, they're not going to blow off. Well, guess what? The original ideal CG on this thing was in a certain place. But if I drastically change the aerodynamics of it, I can probably get away running that CG further back. Now remember, on a rigger has no lift. You wind up running your CG much further behind the sponson. You know, you usually put a turn fin way back here and put the CG on the turn fin. So dumping all this air like I'm going to, I might be able to get away with a further aft CG before this thing wants to go poof. So we'll do a little more tinkering. I still have to get the coupler. The coupler will be the last thing. I need to determine the length of this. How long will this be in order to allow the end of the coupler just to clear the deck and have room to unscrew and screw, have room to go through its connection things. So that's where I want everything. I want it as tight as I can. Once everything is glued into this, then this can get glued into here, and we can finally make some progress. But, a Rube Goldberg device like this, it takes a while to create. And, it's got to be precise. Until next time, boys and girls, jet out.